Welcome back, grade 8s. This is Chemical Change Lesson 4, and in this lesson we are going to look at two specific reactions and how to represent the chemical change. First of all, on page 110, we need to look at the terminology that is described on page 110 in your textbooks, and that is the meaning of reactants and the meaning of products. So the reactants are the elements or the compounds that participate in the chemical reaction, and they are always written on the left-hand side of the arrow in the reaction equation. The products are the elements or the compounds that are formed during the chemical reaction, and they are always written on the right-hand side of the arrow in the reaction equation. So our examples, firstly, we are going to look at copper chloride going to copper and chlorine. Now, copper chloride is a combination of two elements where there are strong forces of attraction between copper and chlorine. And the copper chloride is broken down into copper and chlorine, so the two elements are separated. So this reaction is called a decomposition reaction. For this reaction to occur, we need electric energy. So energy is put into the copper chloride to break it up. On the left-hand side of the arrow, we have the reactant. So copper chloride is the reactant. And the copper and the chlorine would be the products. So this is one way of representing the chemical change between that copper chloride undergoes. Now, the things that we will see during this reaction is the copper that forms is a reddish-brown color. And the chlorine that is formed is a choking gas. Actually, it's a toxic gas. Now, this is one way of representing the reaction. The other way is with diagrams. Now, you don't know it yet, most probably, but copper is a metal, and I will represent it like this, and it clings to two chlorine atoms. So I'm going to represent the chlorine atoms like this. Now this, with some electricity, forms copper, and chlorine is a diatomic gas. So the two chlorine atoms cling together in a chemical bond. Then the third way is in terms of symbols. Now, copper is Cu, Cl is chlorine, and you'll have two chlorine atoms joined to the copper atom. We use some electricity here. And it makes copper and chlorine. Now take note that the two chlorines in the copper chloride each one is joined to the copper. So these bonds, they must be broken for the two chlorine atoms to come together to make chlorine. And the copper will then be a pure element on its own. And this diagram represents one atom of copper to one molecule of chlorine. A molecule is a particle that forms because of a chemical bond between two atoms. And the atom is on its own. Now, the next thing I'd like to explain is the ratio between the reactants and the products. One copper chloride will form one copper atom and one chlorine molecule, and those ones we get from the coefficients. In mathematics, you learn about coefficient. It is the number before the x or the a or the y. So you've got a 1 before the copper chloride, a 1 before the copper, and a 1 before the chlorine. So the ratio between the copper chloride, copper, and chlorine is 1 to 1 to 1. The second example I want to look at is hydrogen and oxygen making water. Now here you have two elements that join up to form the compound water. So this is called a synthesis reaction. Here we need heat energy for this reaction to take place. And the hydrogen and the oxygen, that is called the reactants, and the water is called the product. So this is one way to represent the reaction in words. In diagrams, we must remember that hydrogen is diatomic, so it is a molecule formed by the chemical bond between two hydrogen atoms. Oxygen is also diatomic, but the atom of oxygen is much bigger than the atom of hydrogen. There we have our diatomic oxygen, and these bonds break. The bond between hydrogen and the bond between oxygen and oxygen break, and then they come together as oxygen with two hydrogen atoms joined to the oxygen atom. Now if we look at that as it is, it looks like one oxygen atom has been destroyed, but it's not possible to create or destroy elements or atoms during a chemical reaction. So we need another oxygen in this, and this oxygen can't come without its two hydrogens on the product side of the arrow. Now it looks like we've created two more hydrogen atoms, but that's also not possible. So we need to add two more hydrogen atoms in one hydrogen molecule to balance the equation. Now we have the same number of hydrogens on each side of the arrow and the same number of oxygens on each side of the arrow. This last way of representing chemical change is using symbols. Now the symbol for hydrogen is H2 when it is considered the diatomic molecule. The symbol for oxygen is O2 when it is a diatomic molecule, and the product's symbol is H2O. But now we see that from the diagrams, we can see that there are 2 molecules of hydrogen and 2 molecules of water is formed. So the ratio between the reactants and the products is given as 2 hydrogens, 1 oxygen, and 2 water molecules. I hope you found this lesson useful.